Welcome everyone to another Omega Matters, where we talk all things omegas. Today we are going to look at a recent publication that presents another omega-3 index world map, except for it's not. So we're going to get into why the definition of omega-3 index, why it matters, and take a look at these two big groups of data sets and see how they match and don't match. So take it away.
Great. Thank you for having me. Again, we like to keep in mind what our customers are asking us about. And this particular study we'll get into a little bit later is one that we're getting a lot of questions about. And so we thought we'd try and clarify it with a OmegaMatters event. So why do different companies provide different values for blood omega-3 fatty acids? And so we'll compare two world maps and we'll explore why that happens. Okay, let me see if I should get this. So here is the first world map. This one we published with our colleague at the Fatty Acid Research Institute, J.P. Schuhart, last year. This is based on the red blood cell EPA-DHA, which is by definition the omega-3 index. These data were, the colors were assigned in this particular map based on published studies. Not necessarily samples were run in our laboratory, but everything here has been converted to a red blood cell EPA-DHA equivalent. And hence we have colors from bright green, which is good, which is over 8%, which is our target optimal omega-3 index level. We have some reds, which are under 4%, which is not good. And then in between orange and yellow are on the way toward green. Notice there's a lot of countries for which we haven't got good data, good published data.
Yeah.
But this is the map that, again, the most updated map based on the omega-3 index.
From our researchers, from the studies that we've been able to convert to a red cell level. Why is red blood cell an important part of the definition of the omega-3 index?
Wow, that's great, because that's the original idea. That's the original proposal. And I'll go back to here, our scale. Most of our customers are familiar with this. We say desirable is 8 to 10%, 8 to 12%. Well, what does that come from? And it based is a red blood cell EPA DHA level. And where did we get it? Back in 2004, when we originally proposed the omega-3 index as a risk factor for heart disease, we looked at the existing literature at the time and found that these studies here on the right, these are the omega-3 estimated omega-3 index levels from multiple studies that were associated with the greatest protection against heart disease. We simply took the approach of, well, what's the average? The average of all these numbers was 8.1%. So in the original paper, we proposed that 8.8%, rounded down, is a reasonable target for this brand new metric that nobody had ever heard of before, the omega-3 index. And we set that as our optimal target.
And that was kind of, you also had a low level, because you're always comparing against the group that's the lowest.
That's right.
And that was less than 4%.
Less than 4%. And we left the intermediate zone between 4 and 8% as intermediate. It's better than bad. It's not quite as good as optimal.
Everything is a spectrum here.
Everything's a spectrum, exactly.
And the other point that's, I think, interesting is it's not that these aren't like typical levels necessarily. It's not just what's measured in people. It's actually connected to health outcomes rather than, well, most people are at this level, so that means it's good or bad. It's the people who have less health issues down the road have these higher levels, and that's the target.
Right. Many of the laboratory tests that you get from your doctor, your blood sugar level, well, it's maybe not a great example.
No.
Your blood calcium, your sodium, your albumin, lots of tests that come from a what's called a SMAC, a clinical panel. those levels of those molecules in your blood are pretty much set by metabolism. And we can define normal as what is normal for a healthy population. But for things like cholesterol or the omega-3 index or blood glucose, just because it's the average of a population doesn't mean it's healthy.
Mm-hmm.
I think that's your point, right?
That's correct. Yeah.
Yeah. And so that omega-3 index falls into that category of things that you can move around, and even the normal might not be healthy. The average may not be your goal. Your goal is something different than what's average. And that's certainly the case for the omega-3 index. We did, just to emphasize why we still think the 8% target is good. We did some studies about 4 years later. This is from what's called a case control study, where you really can't look at risk for disease. You look at what's called odds for having a disease compared to a control group. And here we had about 768 case control pairs, meaning a case is a person who was admitted to the hospital with acute coronary syndrome. We got blood when they were admitted. The controls were people matched for age and sex who were just coming to the hospital for outpatient blood draws. They were not having a heart attack. Mm-hmm. So then we compare them. We ask, well, what are the odds of being a case if your omega-3 level is over 8%? And it turned out that the odds of being a case were 70% less likely than if you were under 4%, if you had an 8% target. So this is not a relative risk like you see in some more prospective studies. This is an odds ratio, but it simply shows that there's a connection and that the 8% target is a rational place to set your goal as optimal. So this was one of the studies that we looked at. Here's another study. This is more prospective, more relative risk related than just cross-sectional. Here we have 10 different studies pooled together, over 27,000 people. And we looked at risk for fatal coronary heart disease. And pooling these studies, we had an 8%, you were 35% less likely to have fatal coronary heart disease than if you had a 4%. So again, 35% sounds like not as much as 70%, but it's a huge reduction in risk in the way we normally think of how different blood markers predict risk. And again, prospective studies are different than cross-sectional studies and what you can estimate.
Yeah.
Here's another one, completely different. This is the Women's Health Initiative memory study. Here we're looking at the omega-3 index, its ability to predict risk for death from any cause. And we again measured blood omega-3 index level and the red blood cell EPA DHA in these women at baseline. Then after some 10 or 12 years of follow-up, we found that the women who had an omega-3 index over 8% were about 30% less likely to have died than the women who had a baseline omega-3 of 4%. So again, confirming 8% is a reasonable. Is it perfect? Nothing's ever perfect. It's a reasonable target.
Yeah,
that's the word. So these are some of the papers that led us to believe that the omega-3 index of 8% is the target we're looking for. So,
and also, so it's set basically on all of this data, but also there are naturally occurring groups of people who have an 8+% omega-3 index. They're typically high fish consumers.
sure,
It's not only
Japanese,
accessible
Koreans.
through supplementation,
Absolutely.
I guess.
Right. That's right. And so there's some natural experiments out there that show that. So coming to the topic of the this podcast, or this OmegaMatters episode, here is a paper that was published by Martina Torreson and colleagues in the journal called Lipids and Health and Disease just a few weeks ago. Global variations in omega-3 fatty acid status and the ratio insights from 500,000 whole blood, dried blood spot samples. And I commend them for exactly saying what this is. It's whole blood, dried blood spots. That's a critical feature. And I want to just point out the first two authors are from a company called Zenzino in Sweden. Norway is a subsidiary, but Zenzino is a Swedish company that is selling these blood tests around the world. And so this information that we're getting here is from that company. So when I say why do two different companies show different results, I'm talking about OmegaQuant and Zinzino. Zinzino is not a laboratory. It's a multi-level marketing company that is using a laboratory in Norway to analyze their samples. So here's the map. And of course, everything's blue here, which is okay. But what's puzzling, what puzzled me when I first looked at it was here's the range of omega-3 levels that they're depicting here in the graph. And it goes from 2.4 to 5.4. And I thought, well, wait a minute, what happened to 8%? And it just didn't make any sense. But they do state in their title that this is whole blood EPA and DHA. And for those of us who are kind of professionals in this field, that light turns on a light, because that's a different thing. It's why the discrepancy in targets, and this is it right here. It's whole blood versus red blood cells. That's why there is a difference in these metrics. And so we're going to walk through how that works and propose what a target values for this particular test should be. So here we are. This is a tube of blood that's been centrifuged, spun in a centrifuge to sediment the red blood cells at the bottom and leave the plasma, which is the liquid part of the blood, at the top with a little, what we call, sometimes called the buffy coat, the white blood cells. And why it's blue here, I don't know. Should be white. But in any event, you can see there's plasma makes up about 55% of the blood, red blood cells about 45%, and there's just a tiny bit from these other cells. And it's important to realize that about half the fatty acids in your blood are in the plasma, and about half of them are in the cellular component, the red blood cells primarily. So they combine together. When you do whole blood, you're getting fatty acids from red blood cells and you're getting fatty acids from plasma, and they're being mixed together. And there's, I'll show you some evidence from our laboratory. This is samples, 100 random blood samples that we analyzed, and we measured the EPA and DHA content as a percent of total in the plasma samples, and the average was 3.3%. We measured it in whole blood, same samples. Whole blood, it was 4.24%, and the EPA, DHA, and red blood cells taken from the same samples was about 2%. So you can clearly see that plasma has less omega-3 in it than red cells do. When you blend them together 50-50, you get something in the middle, and this is whole blood fatty acids. So this explains the problem that we saw with this paper. Here's more data from our laboratory where we show the relationship between the omega-3 index on the bottom axis here, which is red blood cell EPA DHA, and DBS stands for dried blood spot. Whole blood. This is the sample type that the New World Map is using. DBS samples. In OmegaQuant, we use red blood cells. And if you look here, what does an 8% omega-3 index red blood cell correlate to in dried blood spots? About 5.4%. So when you've got a 5.4% on a dried blood spot, that's the equivalent of having an 8% in red cells. It's very good. Similarly, our bottom level, our 4% and below 4% corresponds to about 2.4% on a dried blood spot. So keeping those numbers in mind, 2.4% is 4% for the omega-3 index, and 5.4% is 8%. So we can easily make this transition and realize that Zinzino here is reporting whole blood omega-3 levels. If you translate it to what would be OmegaQuant equivalents, this range of 2.4 to 5.4 is the same as 4.0 to 8.0.
Yeah. And so if this lab was measuring red cells, they would likely be getting a similar number to us. The other thing is we collect dried blood spots as well at OmegaQuant.
That's right. And
we report red blood cell.
Because we're able to, basically using this equation, which is a very tight equation. We can convert a dried blood spot sample to a red blood cell equivalent. And that's what we've been doing for 20 years. So here's a Zenzino report, sample of it. Here, they call their metric omega-3 EPA DHA level, which is a little vague, but it is indeed the level in a dried blood spot whole blood sample. Here is the problem. Their target is based on the omega-3 index, red blood cell.
Yeah.
The test is a whole blood test. It's not a red blood cell test. This target, to be accurate and fit with what we know from OmegaQuant, that should be 5.4%.
Yeah.
That would give them a sample an equivalent of an 8%. And that's the confusion, I think. It is extremely difficult to get a whole blood EPA plus DHA over 8%. That's a very high omega-3 index. And that's what's confusing here. Now in the report, they call it omega-3 EPA DHA level, but if you go to the website and look at the tab, how our results are calculated, they call it the omega-3 index. And it's perfect example. This is exactly what the omega-3 index is. This is how we defined it 20 years ago. And they're saying the target is 8%. In the green, and that is true for the omega-3 index. Unfortunately, they're applying that to a whole blood assay, and that's the mistake that's happening here. Just like to point out a recent review article from Mary Dicklin et al. In the Journal of Nutrition that reviewed commercially available laboratory omega-3 tests, and in this one, we had nothing to do with this paper. That they did conclude that OmegaQuant has the most widely used test with the largest evidence base, the omega-3 index. And I think that's what we've been striving to do for the last 20 years, is to link our red blood cell omega-3 levels with a variety of diseases so it becomes clinically relevant. If it's not linked to a disease, and unfortunately the paper from the Zenzino group doesn't link to anything to diseases. They use our omega-3 index targets as theirs without even citing why they do that. So that's unfortunate and confusing. So let me summarize this brief little talk we're having. Omega-3 values from Zenzino are really lower than those from OmegaQuant because Zenzino reports whole blood and OmegaQuant reports red blood cell, EPA DHA. That's the difference. The target values for EPA and DHA are defined by the research we've done on OmegaQuant, should not be used for whole blood tests from any lab, whatever lab it is.
Well, I mean, unless the lab is proficiency testing with us, or we are actually running those analyses, then any omega-3 test should not be like hitting that. You shouldn't be targeting 8%. Because it could be, I mean, Quest is just a totally different omega-3 test.
Oh, right. There are other labs doing just plasma omega-3, and that's going to be the lower value. So the test has to be tailored to the blood sample type that's being used. And it's important that the test that's being done is linked to clinical diseases. That's how, with the strength I think we have here on OmegaQuant. If your omega-3 index, if your omega-3 EPA and DHA, what they call in their result from Zenzino, is at 5.4%, your status is great. You're roughly an 8% omega-3 index. There really is no need to increase your EPA and DHA intake if you've hit 5.4% on that dried blood spot whole blood test. And that's, I think, hopefully clarifies it. Anything else you'd like to add, Kristina?
I think that's it, and that's all. And it's simple, but also confusing.
Like confusing. It's once you understand it, you get it, but until it's explained, it's hard.
Yeah. Good. All right. Well, thank you very much for walking us through that, and we'll see you next time.
See you next time. Bye-bye.
Bye.